based at the University of Birmingham. And as you can see from the map, we cover the Midlands area. To the next one, Cap. Yeah, so we can see the map, hopefully, yeah. So with that one, yeah, so you can see the university, that's where we're based, in the School of Metallurgy and Materials Science. And we're supporting SMEs in the West Midlands area. And you can see the areas that were highlighted for today's event, the marches, particularly Shropshire, Telford and Wrekin, and Black Country, amongst others. And what we're doing really is giving access to the expertise and the state-of-the-art equipment that's in the department, all at zero cost to West Midlands-based SMEs. Next, please. That's covering all materials. You'll see here we're covering plastics, metals, composite materials, all sorts of things from basic, could be consumer products, through automotive, sports goods, aerospace. And we've got a whole range of facilities that are helping companies throughout the development process, whether they're creating new products or they've got products out in the market that they want to update, upgrade, or even failures that they want us to investigate. We can do short-term projects, typically 2 days or so, and we therefore give you very quick results, very quick outputs. And there's always the opportunity to collaborate with the university on things like KTP and Innovate UK funding partnerships that we can work together on. Next, please. Okay, Kat. Yeah, give you an idea of plastics. Some of the things that we've done with our polymer science team. That's desk research, where we've looked at new and potentially different materials for companies. Sometimes that is a desk research exercise using some of our expertise and some of the research we've done. We'll help identifying materials or constituents of materials, be it impurities potentially. We'll do mechanical testing. And you can see on the right, the picture there shows how we combining our understanding of degradation with time and with temperature, correlating that with the sort of tensile strength in this particular polymer that we're testing here. Companies will come to us when they're looking for processing, perhaps using different additives and different blends of materials to see how they can improve processing, therefore reduce cost of processing. Next, please. Thanks. Yeah, here's an example using digital scanning calorimetry. We're understanding here, the melting point of a particular material here, and that's influencing the processing and therefore the sort of throughput that can come out of that process is one example, and managing and minimizing the cost of that process. Next, please. Yeah, here we worked with a particular company in the Marches, and this company here had developed a coating, and they wanted to see how, by various methods, they could create a spray coating. So we looked here at the viscosity, tried to understand that viscosity at the application sort of temperature. We also looked at potential thinners that could be used as well to aid application. And we came up with a new product working with them that they could then get ready to launch into the market. So that was particularly in the Marches. Next, please. Another good example here is the repurposing of wastes, and that was referenced by Paul in his earlier presentation. Here we've got a company that's working with tyres. Of course, we've had this upsurge of cycling, and with it more tyres and inner tubes that need recycling. With this particular company, we've been able to help them create new products. So the wastes and the reprocessed waste is now going into different applications for flooring, potentially in building products and some other applications. Okay, next. Here's a good example as well, referring back to people seeing the benefits of plastics. even in this current environment, with this current sort of mood that people have towards them, particularly the uninitiated. And here, going from left to right, there was a company looking to replace a metallic component, and that metallic component was subjected to various forces. You'll see on the left how we modeled that with finite element modeling, and you could see the distribution of stress on that particular material. What we then did on the right was we tried to replace a couple of millimeters of metal with different thicknesses of a plastic, in this case polycarbonate, and you can see going from the 13 millimeter to the 10 millimeter version, we've managed to again move to a different material. We've also managed to understand with the forces where we needed to reinforce that new material. So we've got a great potential application for plastic. Could be a virgin plastic, could also be a recycled plastic that goes into that application. And selecting that plastic also forms a part of some desk research that we've done. Next. Okay, so what do the SMEs say? We've got some reports and countless sort of responses from customers. Most of them good or very good. And here we see, excellent communication. That's what you get when you're working with AMCASH. You get good, simple, presentable information that's easy to understand, and we go through our reports with you. Feedback here refers to marketing strategy, where a company's been able to formulate a marketing strategy, and similarly below with the company here, Velarim, who've identified business partners, as well as being able to create a process working with us and with other organizations, I must say, but pulling together in the end something that is marketable and potentially quite profitable. Okay, next. Okay, so that's a quick run through AMCASH. You can contact us in terms of the business engagement team. We've also 3 colleagues here today who might find themselves on your tables and talk to them about how we might support you. Okay, thank you. Thanks, Kat.